Okay, we're back. Number 17, we're graphing the line and labeling at least 2 points. And 17 is y equals negative 1/3 x plus 2. Please recall that this always gives you slope. This always gives you the y-intercept. This y-intercept is 2. There's 2 on that y-axis. This slope is negative, so that means that your y's are going to be decreasing. This has a vertical change of 1 and a horizontal change of 3. Count up 1 unit over 3 units, up 1 unit over 3, again and again. And these go on forever, so that's why I always put my arrows on either end. And there's 17. Let's do 18 now. No, we do 19 next. 19, all the y's are 4. All the y's are 4. We did a problem similar to this earlier. Do not let these trick you or fool you. All the y's are 4, no matter what the x's are. So let's just pick some x's that'll work. It doesn't matter what x's you pick, whatever ones you like the best. And now let's graph these points. So negative 3, 4 is a point on this line, 0, 4 is a point on this line, and 3, 4 is a point on this line. And on forever and ever and ever. And that's the graph of y equals 4. Let's find 21. So 21, you know, I'm going to leave 21 for you because 21 and 19 are remarkably similar. Let's go to number 23. On 23, you're asked to state the slope. Well, the slope is embedded in that equation that is solved in terms of y. And so we have to solve for y before we do anything else. I'm going through these steps a little quickly because we've studied these steps in a unit 1. What was it, unit 2? They're all running together for me. Reduce that fraction. Reduce that fraction. Remember, this is the slope. This is the y-intercept. You are asked for slope. Now, for reasons that don't seem to be clear to too many people, slope is m. It's probably Latin for something. Although I have Googled it and gotten no one seems to know, which I think is funny. All right, there's 23. Now, let's go to 25. So, this is going to take some preaching on my part. Pardon this squeaky office chair. Now, recall that x is negative 7. All the x's are negative 7, no matter what. And I'm going to pick some simple y's to use. How about negative 2 and 0 and 2? Slope is always the vertical change. So it's the changes this way. So it's the change in y over the change in x, always. And so in order to find change, we subtract. I work at a grocery store part-time, and when I give change, I give what's left over. We're going to find the change. We're going to find the difference. We're going to find the distance between a couple of points. So I'm going to choose just this point and this point. So the change in the y's, these 2 points, wrote that completely incorrectly. Apologize for that. Here's the change in the y's. So these are my y's. Over the change in the x's, and make sure you come to the where you started with the same point before. -2 minus 0 is -2. -7 minus -7 is 0. Division by 0 is undefined. So what that means is that the slope for x equals -7, m is undefined. Alrighty, where am I? 27. A lot of material in Unit 3. Kind of all over the place. 27. So on 27, we are given two equations. And we are asked to decide if they're parallel, perpendicular, or neither one. So we're talking about slopes. But why don't we just graph this and find out? And I'm going to, just because 20 won't fit on my graph, I'm just going to change it to 10. Just for demonstration purposes here. So you can always graph to see if the lines are parallel. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a positive slope, so the y's are going to increase. A vertical change of 1, a horizontal change of 6, up 1, over 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6. Okay, so there's that one. If this line's parallel, it better be doing the same exact thing. There's nothing here. I'm going to add a 0 so it doesn't change the value. So starting at 0, now this one, remember how we turn a whole number into a fraction? This one has a vertical change of 6 and a horizontal change of 1, positive. 1, 2, 3, 4, 5, 6, 1. Well, you can already see 1, 2, 3, 4, 5, 6, 1. These lines are anything but parallel as soon as they intersect at all. So parallel, perpendicular, or neither. Now, perpendicular means that they intersect at a perfect right angle, just like the squares on this grid. So for 17, we say neither. They just intersect. They're not parallel or perpendicular. Let's go to 29. We have this one, this one. Okay. I've got a lot of solving to do. So I'm going to do this one first. 3y is 6x minus 1. Y is 2x minus 1/3. Solving this one. 2y is negative x plus 10. Y is a negative 1/2 x plus 5. And so here are my two equations to graph. Okay, let's hang on to that idea and get those on the graph and see if they are parallel, perpendicular, or neither one. Now, the intercept is really not relevant when we're talking about parallel, perpendicular. A negative 1/3 intercept is going to be a little bit weird to think about, so I'm going to just change this to -3 because it doesn't matter and it's just going to confuse the demonstration. Let's graph this one first. Slope, y-intercept, 1, 2, 3. Going to make this whole number into a rational number with a vertical change of 2, horizontal change of 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, a whole bunch of times, 2, 1, 1, 2, 1. Okay, so there's this guy here. Now let's graph this guy here, starting at 5. 1, 2, 3, 4, 5. It's a negative slope. The y's are going to decrease. Vertical change of 1, horizontal change of 2. 1, 2, 1, 2, 1, 2. Now for this one, I do want to connect with a solid line because this is going to be important to see. I want you to see that they're perpendicular. Matter of fact, I'm going to slide a sheet of paper in there. Those lines are perpendicular. Now, it's interesting to see what you notice about the slope is going to cause them to be that way. Connect Math does a nice job of that for you. So with this, you have notes for every single thing. And I hope you let me know if you need help. That's what I'm for. Of course, I can't see you, but I certainly don't hear from you guys enough. So I'm assuming you're getting everything that you need if I don't hear from you. So until next time, do math every day, and reach out to somebody if you need some help.